Hello everyone, this is your tutor AB. Today we're going to be solving a problem from the IB Physics HL May 2024 examination. This is a paper 2 problem from the Times Z2 paper. Okay, this is a mechanics problem. Let's get started. A ball of mass 2.7 grams is released from rest from a height of 28 meters above horizontal ground. So here's a diagram that depicts this scenario. So part A, show that in the absence of air resistance, the ball impacts the ground with a speed of about 23 meter per second. Okay, this is a really straightforward question. We just employ our kinematics equation. And here we can just, because we have no time, we can use our timeless equation, which is v square minus u square is equal to 2as. Okay, and we know that the ball starts at rest, so we know basically that v square is equal to 2as. So v is equal to the root of 2as. Okay, so that's the root of 2 times the acceleration due to gravity 9.81 times by the displacement of the ball, which is 28. So we get that the velocity is equal to, let's put this in our calculator, 28 times 23.44 meter per second, which is approximately 24 meter per second. Okay, next question. An air resistance force F acts on the ball. F can be modeled equal to kv square, where v is the speed and k is a constant. Determine the units of k in terms of fundamental units. Okay, so F we know is force. Now, what is the usual units for force? Well, force is mass times acceleration, usually, right? And so mass is in kilograms and acceleration is meter per second square. So we know that kg meter per second square must be equal to the units of kv square, which we can say is k times, and the velocity of v is of course meter per second, so meter per second whole square. This way, if we equate this, we can solve for k and find out what's the unit for k. Okay, so here's what we can do. Let's expand this. So we get kg meter per second square is equal to k meter square over second square. Now second square and second square will cancel, right? And so we're left with k is equal to kg, and then because meter square will go to the other side, kg per meter. And that's your unit for k, kg, kilogram per meter. Okay, now describe how the ball reaches terminal speed. When does terminal speed occur? Terminal speed occurs when the summation of forces in the y direction is equal to 0. So that means that the weight of the ball is equal to the air resistive force. And at this point, the ball will reach the terminal velocity or terminal speed. Because we know that air resistive force is kv square, and as the ball drops, its velocity will increase, and it will eventually increase to a point where its air resistive force will be equal to the weight, which is m times g. And at that point, at that velocity, we have reached the terminal speed. Okay, and that's how that works. Okay, the graph shows the variation with time t of the speed v of the ball from the instant that it is released until it impacts the ground. State the value of the area under the curve. Okay, now we know, although calculus isn't in the physics syllabus, we know that the area of the under a velocity time curve is displacement. The integral of a velocity time graph will give you displacement. And so we know this is from the instant it is released until it impacts the ground. So this whole area under this graph will basically tell us the total displacement from the instant it is released to the time it hits the ground. And we know that the displacement was 28 meters. And so that's the same here. 28 meters is our answer. Now they tell us to determine k. Okay, so when did I say V equal terminal speed? The summation of y forces is equal to 0. So we'll be able to determine k if we basically equate mg, which is the weight, to the resistive force kv square, which they gave us earlier. Kv square is the resistive force, right there. So when this equation is true, the ball is currently in terminal speed. Its summation y forces are equal to 0, and using this we can solve for k. So what's the weight of the ball? The mass of the ball was given to be 2.7 grams, so that's basically 2.7 by 1000 because we want it in kilograms. That's 0.0027 times by gravity, acceleration due to gravity, which is 9.81, all over the velocity squared. Now what's the velocity when it has reached terminal speed? That is approximately this point right here, which is 9.5. Okay, so its terminal velocity is 9.5. So 9.5 the whole square. Okay, so this will give us k. And basically, by going up, we can say k is equal to, let's put this all in our calculator, 0.0027 times by 9.81 divided by 9.5 the whole square. And that basically gives us k is equal to 2.93 times by 10 to the power of negative 4. And that's the value for the k constant. Okay, question 1 continued. On the axis below, draw a graph to show the variations of the magnitude of the resultant force F on the ball with time t. Now, what exactly is the resultant force on this ball, for instance? You're going to have the weight, you're going to have a resistive force. Let's just like forget about buoyancy for in this case because it's not important. Resistive force is basically just your drag force, your drag and your weight. Okay, that at a point in time your weight will be greater than the drag, but eventually as time goes on your weight will be equal to the drag, and so your resistive force at one point will become constant. First, your resistive force is going to of course start off at 0. Your resistive force will start off that, and eventually it will level out, something like that. Your resistive force will keep decreasing as your weight is greater than your drag, and eventually your weight will be equal to your drag, and so it looks something like this. It'll be like a inverse graph which starts at 0 because time at 0. Okay, it looks something like this. Okay, calculate the average power dissipated by the air resistance force. Okay, now what is power? Power is nothing but your work over change in time, work over delta t. And now what is work? Work is basically a change in energy. So we can basically say power is nothing but the energy, the total energy at the start, ET initial, minus the total energy at the final, and this over the total time will give us the change in power. Okay, that's what they want, the average power. So what is the total energy at the beginning of this motion? Well, total energy is comprised of potential plus kinetic energy. So basically write it like this. At the initial you had half mv square, half m, the initial velocity squared, plus the potential energy squared, mgh, this thing, minus your total energy final, which is your half m v final squared minus mgh final. Okay, and this thing, of course, the whole motion takes place for about 3.6 seconds. You can see right here about 3.6 seconds. Okay, and so what I'll do, I'll just zoom out a bit and work right here. Okay, so what's the initial velocity? The initial velocity for this ball will obviously be 0. There is no initial velocity. right? So the ball initially has no kinetic energy, it has only potential energy. So we can say power is equal to mg, and then h we know is 28, but h we just keep it like that. And at the final we know that the ball has a kinetic energy but no potential energy, because it's h, the final height is 0. So this will cancel and that will cancel, so you're left with half mv final squared, and this whole thing over 3.6 seconds. Now let's plug in all the values that we know. So we know that power is equal to the mass of the ball, of course, 0.0027 times by, let's just make it give more space, times by the gravity, 9.81, times by the initial displacement, which is 28 meters that was given at the start, right, minus half, and the mass of the ball again we know is supposed to be equal to 0.0027 times by the final velocity, which in this case was given to be 9.5 meter per second whole square, and this whole thing over 3.6 seconds. This would tell us the average power dissipated. So power is equal to, sorry for the messy handwriting, I should have probably thought this through at the beginning, noting how much space there was in the box, but it's okay, these things happen. 28 minus times by 0.0027 times by 9.5 whole square, 3.6, and that gives us an answer of power is equal to 0.17 watts. That's the power dissipated during this full motion. Now just to sum up what I did, power is nothing but a change in energy over time, and we want to find out what's the total energy at the beginning of the motion, what's the total energy at the end of the motion. Total energy is made up of two components, the potential energy and the kinetic energy, and so we find out what's the potential energy at the start, the kinetic energy at the start, the potential energy at the end, what's the kinetic energy at the end. We find out that at the beginning there is no kinetic energy and at the end there is no potential energy, and so it's basically mgh initial minus half mv square final, and that basically gives us this expression at the end divided by 3.6 seconds, which is the total time for the motion, and that gives us the average power dissipated. Okay, now finally the ball rebounds from the ground with a speed of 7.8 meter per second. The ball is in contact with the ground for a time t. The average resultant force on the ball during this time is 1.1 newton. Determine t. Okay, so anytime your ball strikes the ground and bounces back, there is something known as impulse. Impulse is just this: J is equal to F delta T. This is the impulse formula. Okay, because there's a change in force. Not a change in force, but the change in how long a force acts on an object during a given amount of time. That's impulse. Okay, so using this impulse formula, we can solve this question. Now, what is impulse? Impulse is nothing but a change in momentum. That's equal to F delta T. And momentum, as we know, is equal to mass times velocity. So we can basically say is the mv final minus the mv initial all over the force. That will give us the time, right? And so let's solve this. We can factor out mass and we can say the final velocity of this is 7.8 meter per second, that's the rebound speed, minus of, and the speed at which it hits the ground we know is 9.5 meter per second. But we know that they're in opposite directions, right? 7.8 is in the upward direction, 9.5 is in the downwards direction. So it'll be 9.8 minus of minus 9.5 all over the force, and the force was given as 1.1 newton, and that's equal to time. So we know the mass, so we can basically solve for time. So T is equal to the mass of the ball, 0.0027 times by, put this in your calculator, which is basically 7.8 plus 9.5 all over 1.1. So time is nothing but, let's put this in your calculator, 0.0027 times by 7.8, sorry, plus 9.5 all over 1.1, and that gives us the time in which it's in contact with the floor to be about 0.042 seconds. Okay, thank you for watching. Please like and subscribe. If you have any questions, leave it down below and I'll answer it as soon as possible. Thank you for watching.